Number 37. Which equation can be, and this is not choice D, which equation can be represented by the equation 3s minus 25 equals 80? So it looks like we have maybe three things here, three s's, whatever that may be, minus something, minus a constant, and whatever it is, it equals 80. A, Marissa bought 25 sweaters for $3 each. Well, if she bought 25 sweaters, it would be 25 times 3 or something like that. You would see that. Marissa bought S sweaters for $25. Well, no, that's not the case because, again, 25 is our constant here. You want to see something, you ideally want to try to find something that says less 25 or minus 25 or something like that. C, Marissa bought 3 sweaters for S dollars each. Okay, that looks like that might be reasonable with 3S. With a $25 discount, minus 25, for a total cost of 80. Choice C. And D, Marissa bought 3 sweaters for S dollars each and then bought a hat for 25. Now, if this had been 3S plus 25, that would be right. But it was 3S minus. In which quadrant is point C located? That is going to be in quadrant 1. What are the coordinate points for B? Well, remember, we do the x-axis first, then we do the y-axis. X is 1, 2, or excuse me, negative 2. B is negative 5. Negative 2, negative 5. What are the coordinate points for G? Well, let's take a look at G. G is negative 3 on the x-axis, so we say negative 3, and remember x comes first because x is first in the alphabet. Then on the y-axis we are negative 2. So that is for point G. What point is located at 2, negative 5? So we go 1, 2, 1, 2, 3, 4, 5 is J. What is the location of point B? We've got positive 5, negative 4. So we got 5, negative 4. Now, 3 points on the plane are vertices of a rectangle. Rectangle has 4 sides. Which coordinates name the fourth vertex? So I got to find the 4th point. Well, in order for us to have a full rectangle, I got to draw that guy on out. I got to draw that guy on out. And the point, or the vertex, is going to be right there. That is at negative 2, comma, positive 2. Number 42. The graph below shows a relation. In other words, as one variable it does one thing, another variable is going to do another. Okay? Which table of values also represents this relation? So we've got it here, and then we want to show a table or of values here and see which one of those equals. Well, in order for that to be the case, you have to just take a look. The easiest thing to do is just to take a look at your coordinate points here. And let's take a look at them one at a time. We've got first one here, and let's just take this one for example. We've got a positive 1, so we got 1, negative 2. Let's take a look at 1 or 2 more. Let's take a look at negative 2, negative 4. And then one more, we'll just look at this one right here. Negative 3, negative 2. Negative 3, negative 2. And what we need to do then is try to find some points down here that have those here. And they have to be exactly the same. So we've got 1, negative 2. I see that here in A. I see that here in C. So no, those are possible choices. However, I don't have it in B and I don't have it in D. So we can eliminate those two. So I've got a choice between A and C here. Let's take a look at negative 2 and negative 4. Do we see that in A? Well, we got it right there, right? Do we see that in choice C? Well, we got negative 2 here, but that's negative 3. Therefore, that is incorrect. So we can eliminate choice C. A is our answer. Basically, these points need to have the same as these points right here. Which statement is true of the ordered pairs shown below? We have our input, which is always x, 0, 3, 6, 9, and 12. For our output, we have 0, negative 9, negative 18, negative 27, and so on. So the question is, what statement is true about this? For each ordered pair, and this is an ordered pair here, 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 and this is an ordered pair here. Now sometimes we're going to be comparing x to y, but here it looks like we're just looking at the ordered pairs individually. For each ordered pair, the output, which is y, is negative 3 times the input. Well, 0, 3 times 0 is still 0. Negative 3 times 3 is negative 9. Negative 3 times 6 is negative 18. Negative 9 times 3 is negative 27, and so on. So it looks like that might be the best choice. For every ordered pair, the output, which is y, is negative 3 times the input. Well, let's look at the choices. Let's just make sure. For each ordered pair, the output is negative 1/3. That would mean that we would multiply that by 1/3, or negative 1/3, and we would get 1. Well, that's not the case. We can eliminate that. For each ordered pair, the output is 6 less than the input. Well, that's not the case in any of these, so we can get rid of that. And then again, the output is 12 less than the input. That is also not the case here. Our answer is A. (44) Which equation could represent the relation shown on the grid? Well, all we would have to do is plug a few of these in here, and every one of these dots has to be able to fit into that equation for it to, sorry, not every one of these dots, but every one of these coordinate points would have to solve this. Would have to, in other words, the right answer will be a solution for every ordered pair. So we would plug in, this ordered pair right here is 3, negative 3. And let's just take a look at this one right here also. 2, negative 2. 2, negative 2. And let's just plug those into all these and see if they're right. Well, A, y, which is always the second one, so is that negative 3 equals x 3 plus 6. Is that true? No, we can get rid of A. Well, let's go ahead and keep with this ordered pair, because again, all we just need to make sure one of them works. And if it doesn't, we can eliminate that choice. Y, which is negative 3, equals 3 plus 4. Is that true? No, obviously not, because that's 7. Y, which is negative 3, equals negative x. Well, I think that is the case, because negative x, the opposite of that is number 3, or negative 3. So let's go ahead and plug this one in too, because it looks like C might be the right choice. Negative 2 equals negative 2. It looks like C might be a viable choice. And then y equals x. Well, obviously y does not equal x here, because this is 3 and this is negative 3, this is 2 and this is negative 2. So our choice is C. Which equation best represents the relation shown by the ordered pairs in this table? Again, we would need to just plug a few of these in here and see which one is correct. Well, let's go ahead and plug 0, or I tell you what, let's go ahead and just use this guy right here. And if we find that that does not solve that equation, then that is automatically not a choice. Y, remember which one is x and which one is y. Y, so we got negative 1 equals x, which is 2, minus 2. Well, 2 minus 2 does not equal negative 1, so that is not a choice. Let's go ahead and plug it in here. Y, which is negative 1, equals x, which is 2. Oh, I'm sorry, I did this one here. So this goes here, excuse me. Now I'm going to go ahead and do that there. Please forgive me. Y, or 1, equals 2, which is x. Excuse me, negative 1. minus 1. Well, 2 minus 1 is 1, not negative 1, so that's not a choice either. Let's go ahead and try C. Y, which is negative 1, equals x, which is 2, over 2 negative. Well, negative 2 divided by 2 is negative 1, so it looks like this might be a choice. Let's go ahead and circle it. Let's go ahead and try the last one, though. Y, which is negative 1, equals negative 2 times x, which is 2. Well, negative 2 times 2 is a negative 4, which is not the same, of course, as negative 1. That is not right. Our choice is C. So the easiest thing to do when you get ones like that is just plug a few of them in. And usually you only have to look at one. Almost always you only have to look at one. You might have to do 2, maybe 3 sometimes, but you know for a fact that if 1 does not fit and does not make it equal, then it's automatically eliminated if you have a question like that. Which equation best represents the relation shown by the ordered pairs in the table? Again, let's go ahead and plug some numbers in. Please don't get confused with x and y. Let's go ahead and use A. And let's just use this one right here. Y, which is negative 5, equals 3 times a negative 4 minus 1. This turns into 5 equals negative 12 minus 1. Well, that's negative 13. That is not a choice. Okay. B. Negative 5 equals 2 times negative 4 plus 3. Well, this is negative 5 equals negative 8 plus 3. Oh, looks like we have a choice here. Negative 8 plus 3 is negative 5. And negative 5, of course, does equal negative 5. That looks like that might work. Now let's go ahead and look at the other choices just to make absolutely sure. Negative 5 equals negative 4 over negative 2. No, that is not true. C is not a choice. And finally, let's take a look at D just to make sure. Y, negative 5 equals negative 2 times negative 4. Well, negative 2 times negative 4 is 8. And that is obviously not equal to negative 5. Our choice is B. So again, just plug those guys in. Now, for which table of values is it true that as x increases by 1, y decreases by 2? We're asking you to make a comparison. So as x is doing something, y is doing what? And we're in this case is asking us which one of these choices, as x is increasing by 1, and we can see in all choices x is increasing by 1 in every one of them, what is happening, or y is decreasing by 2? So all these are going up by 1. Which one of these basically says y is decreasing by 2? Well, y isn't changing here. Y right here, it appears to be going up by 1/4 every time. Y here appears to be increasing by 2. Now y here is decreasing by 2. The choice is D. Now they're going to straight out ask you. We have a table right here. What happens to y? We're asking about y as x is increasing by 4. So this is going up by 4. This is increasing by 4. What is y doing? Well, y is also increasing by 4 as well, because we're going from negative 9 to negative 5. That's an increase of 4. That's another increase of 4 going up to negative 1. And this is another increase of 4. So it is increasing by 4. Again, we have the same type of problem here, number 49. What happens to y? I'm asking about y, not x. When x increases by 1. Remember, I'm not comparing here to here and here to here and here to here. I'm asking you, as x is increasing by 1, what's happening to y? Well, it's obviously decreasing by 1 because I'm going from 5 to 4 to 3 to 2 and so on. Number 50, the equation y equals negative 3x describes a relation. What happens to y when x increases by 2? Well, the only way for us to do this is to make an x and y chart and say, hey, what happens to y as x is increasing by 2? Well, let's start with 2, 4, 6, because I'm saying x, as this goes up by 2, what's happening to y? And then all you have to do is just plug those guys into the equation and say, for example, the first one, negative 3 times 2 equals what? It equals negative 6. Then plug in 4. Negative 3 times 4 equals what? Negative 12. And let's just do one more to make sure we can establish a pattern. Negative 3 times 6 equals negative 18. What is happening as x increases by 2? Y is decreasing by 6. More to come.